Hello. Welcome to the last test review from Chapter 4. Got a lot of problems to work for you, about 15 of them here. And here's the list, so let's get started. Number 3. All right, the antiderivative of 2x squared. So I'm going to add 1 to that 2, so that would be x cubed. But what do I need out front to get a 2? That would be 2/3, right? So 3 times 2/3 would be 6/3, which would be a 2. And then plus the antiderivative for x is 1/2 x squared. And then the antiderivative for 1 is just x. And then don't forget the constant of integration. Okay, for number 5, we don't want to try a u substitution here. We can just divide x squared into each of the two terms and rewrite this as x plus 1 over x squared. And that's going to be x plus x, sorry about that, to the minus 2 dx. The antiderivative of x is 1/2 x squared. And then x to the minus 2, I usually wait on putting the sign here. That'd be x to the minus 1, but I need a negative out front. So negative 1 times negative would be positive x to the minus 2. So getting rid of the negative exponents, that's going to be 1/2 x squared. All right, make sure your x is even with the line in the fraction here. Don't bring it down, don't write it as in the denominator by accident. Minus 1 over x plus c. All right, and that's a good one. Number 7. All right, we've got 4x, so we're going to add 1 to the exponent, x squared. We would need a 2 out front. So when we take the derivative, it's 4x. And then how about plus 3 cosine x? Okay, the derivative of cosine x is minus sine, so that would give us our minus there. So it's going to have to be plus in front. And then plus c. So you have to be careful of those signs. That's why you want to check by taking the derivative. Make sure you get the signs right. Okay, then we've got a velocity problem. So 13, we'll bring this one into view. We've got a ball is thrown vertically upward from ground level with an initial velocity of 96 feet per second. How long will it take the ball to rise to its maximum height? And then what is the maximum height? All right, so we know this is in feet, so acceleration is minus 32. I do expect you to remember that, and that it would be minus 9.8 if you're in meters. V of t, then we're going to integrate negative 32 with respect to t. So that's minus 32t plus your initial velocity, which is 96. And then for our position function, we would integrate the velocity function. So minus 32t plus 96 dt. That's going to be minus 16t squared plus 96t. And it said it's thrown from ground level, so our initial position is 0. So now we have our velocity and position function. Part A says, what is the max height? And we know that the maximum height is where velocity is equal to 0. So we have 0 is equal to minus 32t plus 96. So if I move that minus 32t over to the left, we have 32t is equal to 96. So t is equal to 3 seconds. That's how long it took before gravity started pulling it back down to the earth. And then how high is that? That would be s of 3. Okay, so we're just going to plug 3 into this equation. Minus 16 times 3 squared plus 96 times 3. All right, and that is 144 feet. So that's a pretty good throw. All right, that's a good velocity, acceleration, position problem. You should certainly expect at least one on the test that involves velocity, acceleration, position, maybe even 2. And I believe we had one of those also to do in maybe test review A. Okay, so we're on to number 23. So 23, we're going to integrate x squared over the square root of x cubed plus 3. Now this is going to be a u substitution problem. I can't really simplify this here at all. So you want to pick a u that, if you take the derivative of it, that derivative is sitting in the problem. It might be off by a constant, but we can fix that. So if we let u be x cubed plus 3, then du is 3x squared. That's almost what we need, 3x squared dx. That's almost what we need. We need it to be x squared dx. So if we multiply each side by 1/3, we have what we need. And we can rewrite this integral in terms of u. So we have a 1/3 out front, and then du on the top, the square root of u on the bottom. Okay, let's rewrite that as 1/3. And I'm going to bring this square root of u up. It'd be u to the minus 1/2 du. And now we're ready to take the antiderivative. Don't forget the 1/3. Add 1 to the negative 1/2. Okay, that's going to be u to the positive 1/2. But I would need a 2 out front. 1/2 times 2 is 1, then u to the minus 1/2. So this is going to be 2 times 1/3, so 2/3 times the square root of u plus c. So that's 2/3. We've got to put u back in the problem, so times the square root of x cubed plus 3 plus c. All right, so take the derivative of that. All right, if you haven't done it, give it a try, but you'll get back to this original equation. I'm not going to do that on most of these just to save time, but I will do it on a couple of them as we go. But I'm going to leave that one up to you. Remember, you'd want to rewrite this x cubed plus 3 as to the 1/2 power and then use the chain rule. Okay, 25. So 25, we have x times 1 minus 3x squared to the 4th power times dx. Now, I can't distribute the x across that because this quantity is to the 4th power. We would have to write it 4 different times, so that would be a monstrous thing. But it works well for u substitution because this 1 minus 3x squared, if we take the derivative of that, then that derivative is kind of sitting out in the problem. So if we let u be 1 minus 3x squared, then du is minus 6x dx. We need it to just be x dx. So if I multiply both sides by minus 1/6, I have what I need. And I can rewrite this integral, minus 1/6, and then I would have u to the 4th power, right? U to the 4th power, x dx is du. And now it's a simple antiderivative. I would have minus 1/6 times 1/5 u to the 5th, right? The antiderivative of u to the 4th is 1/5 u to the 5th. So that's going to be minus 1 over 30 u to the 5th plus c. Now you can't circle that. We have to put it in terms of x. So that's minus 1 over 30 times 1 minus 3x squared. That's our u. Don't forget to the 5th power plus c. Take the derivative of that. 5 times negative 1 over 30 would be negative 1/6 times 1 minus 3x squared to the 4th, then times negative 6x, the derivative of the blob, and that's going to get rid of this fraction out front. So I kind of did the check in my head, but it does work. And you will have plenty of room on your test paper to do the check out to the side and you actually write them down. All right, number 27, getting into a few trig ones here. So we would have sine cubed x times cosine x dx. Okay, this is it's multiple trig terms here, so we're definitely going to be a u substitution. So if we let u be, I think the best thing to pick, we could pick either sine x or cosine x, but the easiest one is sine, because du then is cosine x dx. If we let it be cosine, we would have had minus sine x dx. And that would have been harder. But this is really easy. So we can rewrite this as u cubed du. Okay, so the antiderivative of that is 1/4 u to the 4th plus c. So that's plugging back in our u, that's 1/4 sine to the 4th power of x plus c. Now we could check that. I'm going to go ahead and do one where we check it. So I'm saying this is the answer. Let's check it by taking the derivative. So I'm going to rewrite this to help me with the chain rule. It's really that, right? So 4 times the 4th would be 1. So that would be 1, times sine x to the 3rd power times the derivative of the inner function. That's cosine x. And that's exactly this. So our check gave us the correct original equation. So we're good to go. All right, 29. We have sine theta over the square root of 1 minus cosine theta d theta. All right, so I'm eyeballing this, and I can see that if I let u be 1 minus cosine theta, then du is sitting right in the problem. The derivative of 1 is 0, and the derivative of minus cosine is sine. So it's sine theta d theta. That's exactly what I need du to be. So I could rewrite this now as du, it's not even off by a constant, over the square root of u. And that's going to be u to the minus 1/2 du. The antiderivative of u to the minus half, let's add 1 to the exponent, that's 1/2, but we're going to need a 2 out front. So 1/2 times 2 would be 1 times u to the minus 1/2, and that's it, plus c. And now we can put 1 minus cosine theta back in. I'm going to go ahead and write it in radical form just to be prettier. Match the back of the book. So 2 times 1 minus cosine theta plus c, and you could check that if you want to rewrite that as 1 minus cosine theta to the 1/2, and then take the derivative of it. you will get back to the original equation. All right, so give that a go if you haven't done it. Okay, moving right along. Looks like we're a little over half done here. All right, 32. We have secant 2x, tangent 2x. Now the reason this is a u substitution is if it were just x, then it'd be a straightforward, very easy. And you actually probably could do this in your head without a u substitution. But I'm going to do it that way. Let's let u be 2x. du is 2 dx. So 1/2 du would be dx. And therefore I could rewrite this. I tell you what, I actually, that is not going to work. I apologize for that. Let's try something else. So the reason I knew it works is I couldn't get it. Let's let u be secant 2x. Then du would be secant 2 times secant 2x tangent 2x dx. It might have worked the other way, but I saw this, and I really liked how simple this makes everything. So 1/2 du is equal to secant 2x tangent 2x dx. So I could now rewrite that as the 1/2 out front. The whole thing is just du. So that's 1/2 times u plus c. So that'd be 1/2 times secant 2x plus c. And checking that, I'm kind of eyeballing that in my head and doing the derivative. That does come out to that. All right, and I do believe the other way I started out doing it would have also worked, letting u be 2x. You would have had secant u tangent u, and the antiderivative of that would be secant u, and then u is 2x. They both would work. I just thought it was neat that the entire expression ended up just being du. Yeah, both of those. The way I started also would have worked, but when I realized that I could make the whole thing be du, I wanted to kind of do it that way. But if you did it the other way where you let u be 2x, that's fine. That'll work as well. All right, 35. Now we are into the fundamental theorem of calculus, definite integrals. We're integrating from 0 to 4 of 2 plus x dx. That's going to be 2x plus 1/2 x squared. Evaluating that from 0 to 4. So that's 2 times 4 plus 1/2 times 4 squared. And then minus, you plug 0 in. That's just all 0. So that's 8 plus 16 over 2. 8 plus 8. That is 16. All right, awesome. Okay, let's look at 37. So we're going from -1 to 1, 4t cubed minus 2t dt. Okay, the antiderivative of 4t cubed would be t to the 4th minus t squared. And then we're evaluating that from -1 to 1, so that's going to be 1 to the 4th minus 1 squared minus, and I like to put the second half in brackets, -1 to the 4th minus -1 squared. So that's going to be 1 minus 1 minus 1 minus 1. That's just 0 minus 0, which is 0. Awesome. Okay, let's go to 39. So 39, we're going from 0 to 3, 1 over the square root of 1 plus x dx. Okay, this is going to need to be a u substitution because we have a quantity here. We can't really use the power rule. So let's let u be 1 plus x. Du would then just be dx. So I would rewrite this as from 0 to 3 of du over u to the 1/2 power. All right, because it's the square root. That's going to be 0 to 3 of u to the minus 1/2 du. Let's take the antiderivative there. You'd have u to the 1/2, but I'm going to need a 2 out front. Check that. 1/2 times 2 is 1, then u to the minus 1/2. So that's going to be 2. Plugging back in the x version, and then we're going to evaluate that from 0 to 3. So that's 2 times the square root of 4. Remember, 1/2 power is the square root. 1 plus 3 is 4. Minus 2 times, if you put a 0 in here, the square root of 1. So 2 times 2, that'd be 4 minus 2, which is 2. All right, we are killing it. We just got 2 left. Number 41, we're going from 4 to 9 of x root x dx. Now, this is x to the 1/2 power, so I'm going to go ahead and write that out. That's the same as 4 to 9 times x to the 1/2 dx. Remember, x to the first, and you add exponents, so that would be 4 to 9 of x to the 3/2 dx, and that's going to be x to the 5/2, but I would need a 2/5 out front when you take the antiderivative, so add 1, add 2 over 2, that's 5/2. I need a coefficient of 2/5 out front, and we are going to evaluate that from 4 to 9. So that's 2/5 times 9 to the 5/2 minus 2/5 times 4 to the 5/2. Okay, that's 2/5. Now you can just put 9 to the 5/2 in your calculator, but it'd be the square root of 9, and that's 3, and raise 3 to the 5th power. But you don't even have to think about it that way. You can say, what is 9 raised to the 5/2 power? And that is 243. All right, the square root of 4 is 2. 2 to the 5th is 32, but you don't have to know that. So so this is going to be 2 times 243, right? That'd be 486 over 5 minus 64 over 5. Okay, 486 minus 64, I believe, is 422 over 5. And you could put that in decimal if you wanted. It'd be 0.4 times 243 minus 0.4 times 32. All right, and whatever that is. It just depends on your teacher. But in my classes, it would be fine to put that in decimal. And then finally, 45, 0 to pi of cosine x over 2 dx. So you probably could do this in your head because the antiderivative would be sine. So it would be sine x over 2, but you're going to need a 2 out front. I'm going to go ahead and do it as a u substitution. If we let u be x over 2, du is 1/2 dx. I need it to just be dx, so 2 du is equal to dx. So we could rewrite this integral as 2. Out front, 0 to pi of cosine u du. That's going to be 2 sine u, or 2 sine x over 2. Now, take the derivative of that to make sure. That's going to be 2 times cosine x over 2 times 1/2, which is the derivative of, remember you have that times the derivative of the angle, which would cancel the 2 out front. And we are evaluating that, so there's no plus c because it's a definite integral. So that's 2 times the sine of pi over 2 minus 2 times the sine of 0. That's going to be sine of pi over 2 is 1, so that's 2 times 1, 2, minus sine of 0 is 0. And that, my friends, is 2. So that does it for this test review. You got 3 great test review assignments. If you understood all this, you should be in great shape for the test. Good luck on the test. And I will talk to you next lecture.